bisect is the function to carry out the bisect method under the bracketing method category for finding the roots of a function. And there are several inputs for bisect. The first one is func, which is the function that we want to work on to find roots. The second input and the third, which are xl and xu, are the lower and upper bound of the guess. Es is the desirable error, and max it is the maximum allowable iteration. And there are several outputs. The first output is root, which is the real root that are found by bisect. Fx is the fx value at the root position. Ea is the error at the root position, and the iteration is iter is the number of iteration by the time we find the root. So we start with checking how many inputs are there for this function. If there are less than 3 inputs, then an error message will be displayed, which is at least 3 input arguments required. And if we have more than 3 inputs, we can start the test, which is to see if there are sign changes between the XL and the XU position. If the test value is larger than 0, then a error message will be displayed, which is no sign change. This indicates that there is no root in the selected XL, XU section. If ES, the input, is not given, then we have a default value for ES, which is 0.0001. If max it is not given, then we have a default value for max it, which is 50. So next we initialize several values. First is iteration. We initialize it as 0, and also we give the lower bound as the current estimate of the root position, and the error calculation is initialized as 100. The error has a range of 0 to 100. Then we start the main part of this function included in the while loop. First, we store the current estimated root position to xr old, and then we calculate a new estimate root position xr equals the middle point of xl and xu, and also we increase iteration by 1. So now we can start to calculate the error by using the formula given in the bisection method in the lecture, which is the absolute value of xr minus xr old over xr times 100. And of course here xr is on the denominator, so it cannot be 0. And then we can test the xl and xr to see if they have different signs. If test smaller than 0, that means they have different signs. We will give xr. We will put xr to the upper bound and only work on the section xl through xr because we know there is root between these 2 points. Else, if a test is bigger than 0, that means there's no root between xl and xr. In this case, we will give the lower bound xl to the new root position, root position, which is xr. In this case, the middle point. Else, if test equals 0, that means we already find the root. In that case, the error is 0. And so these are how this is the main commands that we use for finding the root position. And the while loop will break if the calculated error is smaller than the desired error, or if the current iteration is exceeds the maximum allowable iteration. And in the end, we give xr, in the end, we have root equals xr. So that's the root position. And also we calculate fx based on this xr value. So next, let's go to the command window and start to have an example that we can call bisect and solve some problem. Here we want to solve what's going on. We want to solve the bungee jumper problem to find the maximum allowable jumper weight. Okay, so the equation is, actually I think I can find it. Yeah, I did this before. So the equation is like this, and once I hit enter, I have this fm function defined so that we can work on the root for this function. And now I'm going to put mass fx ea. These are the outputs of the bisect function, and the inputs are fm, xl, and xu, which are the lower and upper bound for guess. And now if I hit enter, so I will use default value for the desirable error and maximum allowable iteration. So now if I hit enter,